Hey guys, I'm Gunj. Now, what do you think if this happened to you in real life? So, for example, if you were in this building right here, then this would actually happen. So now, if you were inside that building, you would be dead by now. So, how can we prevent this happening to a building during an earthquake? So, in this video, I'm going to talk about this, and so let's take a look. Okay, so what is an earthquake? An earthquake is basically the movement of the ground caused by the shifting of the tectonic plates beneath the Earth's surface. Since tall buildings have foundations which are deep inside the ground, and when the ground moves, the building moves along with it. So when the ground is shaking, the building likes to move in a horizontal direction. So in an earthquake, a building acts like a spaghetti stick. So building inside the ground moves, building moves like this. However, in real life, buildings are not that flexible, and they're very rigid. And if that happened in real life, it'd break like that. Or as we saw in the video, it just collapse over. In order to prevent this from happening, engineers have developed many techniques to make an earthquake-proof building. The most economic and effective way is called base isolation. So, when a building is constructed, it's constructed directly onto the ground through the use of a foundation. Therefore, when an earthquake occurs, the ground moves, causing the building to move along with it. Now, this is not desired. In order to prevent this from happening, we can detach or isolate the building from the ground, essentially floating it in the air. Now, how is this possible? It's possible through the use of lead and rubber bearings, which attach the building to the ground, causing the ground to move independently to the building. Therefore, the building on top can stay still or move a little bit, but not as much as it would have if it were attached directly to the ground. So it basically acts as a car suspension. So as you can see in this image right here, we have a building, we have the ground, and we have the lead rubber bearing. So when an earthquake occurs, the ground moves underneath the building, and the lead and rubber bearings absorb the shock and absorb the shocks and prevent it from going into the building, essentially keeping the building safe and the people inside them safe as well. Another technique to make earthquake-proof building is called a two-mass damper. So basically what a two-mass damper is that it's a giant pendulum ball made out of heavy steel weights, which is hung on the top of a very tall skyscraper, and its purpose is to reduce the frequency of the waves going to the building. During an earthquake, a building moves left and right, and this movement causes the building to structurally fail. And in order to prevent this, a two-mass damper is used. So basically how a two-mass damper works is that in an earthquake, when the building moves to the right, the inertia of the two-mass damper forces it to the left. Consequently, when the building moves to the left, the inertia of the two-mass damper forces it to the right. This counteracts the movement of the building and keeps it as stable and straight as possible, keeping the occupants inside the building safe. Now, as you can see in this video right here, we can see the two-mass damper of the Shanghai Tower at work. It's a 720 ton two-mass damper, which is really heavy, and as you can see, it at work right here. Some of the techniques used to build an earthquake-proof building are the use of specific materials and reinforcement during the construction of an earthquake-proof building. The most important material in an earthquake-proof building is reinforced concrete. Now, as you see in this picture right here, we see concrete with steel bars inside. Now, all of you may ask, what is the purpose of these steel bars? Can't we just use pure concrete? And that's a really good question. However, concrete is a material which is very good in construction of vertical columns. Therefore, it can withstand vertical loads. However, when you spread concrete on a horizontal surface, it's not as strong anymore and it becomes brittle like glass and breaks easily under a certain amount of weight, which is not really much. Steel, on the other hand, is very flexible when it's spread out horizontally and can hold a certain amount of weight with its flexibility. And when you combine steel and concrete together, all you do is combine the flexibility of the steel and the toughness of the concrete together, and you have a very perfect material to build an earthquake-proof building, and it keeps the building structurally rigid and safe. Some other techniques are that you have to use lightweight materials in construction of earthquake-proof buildings, such as the roof should be the lightest part because it has less chances of toppling over during an earthquake. Another important technique is post-tensioning. Now, post-tensioning is used in buildings that are not the stereotypical rectangular box. It's when it's used in like curves and turns. So for example, in the Sydney Opera House. Now, post-tensioning is basically is basically steel wires that go from one end of the concrete wall or structure to the other end, and tension together, causing the concrete to be pulled tightly together and causing it to be very rigid, and therefore an earthquake not being able to break or move apart. Now that we've watched this video, we all know the different types of techniques used to build earthquake-proof buildings. However, there's not just one specific technique that works in every building in the world, because every building has its own specification, such as its geography, its height, and the shape of the building, and the budget of the building. And taking into consideration of all these specifications, any one, two, or three techniques is chosen and incorporated into that specific building. Therefore, without the use of all these techniques, it would be impossible to build a building to withstand earthquakes and save the lives of the people working in that building. Thanks for watching.